And so another important thing with entanglement, and we're getting, I think, almost at the end of what I consider that it's kind of like a good basis for you to then go out in the wild by yourself and explore quantum computing by yourself. Another important thing about entanglement, what I mentioned also a couple of videos ago, is that you're entangled qubits. This means that you've got to be careful because it makes your circuit a bit more unstable in terms of reusability. I mean, it's really common in classical computing that you have some variables and then you assign some values and then you reuse it for something else, right? That's common. That's common thing to do. So here, you would be tempted to do the same, right? I mean, just to have a small. This is not at all a real example. If you check out O'Reilly's book, there's plenty of really useful examples with a bit more qubits. This is just to showcase what I want to say is that if you've got um, so if you've got your if you've got here, let's imagine you've got qubit 0 and qubit 1 are the ones you use to do something, and then the qubit 2 is a qubit that is used as an auxiliary qubit or a scratch qubit to um, uh, usually you'll come across those types of qubits, especially because in quantum computing, to implement certain operations, you will realize that you must use a scratch qubit in order for them to really be doable. But I don't want to cover that here. So check out the book, and you will see examples of, for example, the mathematical operation of calculating the absolute value of a number, right? Because it's if you don't have a scratch qubit, you're not going to be able to implement it in quantum computing because in quantum computing you need to be able to reverse the operations. Otherwise, that sounds weird, but the idea is if you don't have that qubit, when you will be doing your operation, you will basically destroy part of the solution. This is just because of how the space of solutions works. But I don't want to get into details with this. So check out the book for really good examples. What I wanted to show you here is that um, that you should be aware of these. So if you have your here, like your superposition, I don't know, let's say you've got this superposition and you're trying to do something with them, um, like maybe something that might look like this and then like this. I mean, actually that example might be even a good one. That might be even a good one, kind of like a simple addition or whatever, right? And you can think of your carry beat here as being a scratch beat because maybe you want to use it for something else. I don't know, whatever, right? So um, the idea is now you've basically created entanglement, so you cannot simply just uh, reuse these qubit in here. So you gotta disentangle this qubit. Um, you gotta disentangle this qubit because now basically, if you mess up with this qubit, imagine you want to reuse that qubit, right? And you want to do something like, and pay attention. Your qubit 0 and 1, right, are entangled. I mean, sorry, kind of everything is. So your qubit, no, your qubit 1 and 2 are entangled. But the idea here is, look that the qubit 0 and 1 have specific sets of solutions, 0, 1, and 1, 1. Maybe that's relevant to your problem, and maybe that's what you want, right? And then you want to keep that result for later on. And if now you mess up with this qubit, which you kind of just used um, for flagging or something, whatever, if you now mess up with this qubit, look what happens, right? So you basically have messed up with your overall state because you now have other. I mean, they are kind of, in this case it's a bad example. I'm so bad at making examples. I'm sorry for these people. Go check out real tutorials. You will probably find better examples, but you get my point, is that you actually spoil your overall state because you're adding stuff. You're now basically adding solutions that have like another phase and whatnot, and stuff like that, that might spoil the purpose that you originally intended to use these 2 qubits for. So what you got to do before reusing that, you got to disentangle the qubit, and that's something you can do. That's what I wanted to cover here, by simply applying the same operations that have entangled your qubits before, but in reverse, right? In this case, it's just one operation. So if you do that, uh, you have disentangled them. That again, that also has spoiled what you've done here. So you would think, what's the purpose of that? So the trick here is, if you probably add another qubit up here, then you could kind of maybe um, you could use, before disentangling, you could kind of work with these qubits to make sure that you were that you do whatever you wanted to do with this result, and then you disentangle. um, this is the, that's why I say it's tricky. And then you disentangle after this. I'm just going to put some IDs here, pretending that you're doing some work, and then you disentangle. And then once you disentangle, basically you can use that qubit again for something else, without being afraid that you're going to spoil anything else in your system. So that's the gist of this. So basically, entanglement is good and is bad. As I said, be careful with reusing qubits that might be entangled, because they might spoil everything else that you're doing. So that just shows you how tricky this whole thing is.